It's been a while since I make a video. I'm gonna take it from here because the other part we already did. So, what's the medium score? Well, let me allow me to do this. Maybe that helps. So the medium or Q2 is this guy right here. So the medium would be 75. Which score represents the first quartile? This is, so let me write Q1, Q2, Q3. This is the lower extreme and the upper extreme. So first quartile, Q1, that's 70. Which statement is not true about the box and whisker plot shown? 75 represents the mean score. Guys, this has nothing to do with the mean. I have no idea how to find the mean. Because remember, there were a bunch of numbers, and I'm just making this up. 60, 70, 72, 73, all the way to the last number, 100. There are so many numbers, right? And you did the medium, and then you did the medium again, and then the median. Now, in order to find the mean, what do I need? I need to find all those numbers, to get all those numbers, right, that you put in order from least to greatest, add them up, and divide it by however many numbers. I have no idea what those numbers are. The only thing I know is that the lower extreme is 55, the upper is 100, Q1, Q2, Q3. I know those values, but I don't have enough information to find the median score. So 1 is the one that's not true. 100 represents a maximum score. I mean, let's just go through them anyway. That's true. 85 represents the third quartile, right here. That's true. And 55 represents the minimum score. That's true. So the only one here, and again, they're talking about the mean. There's absolutely no way I can find the mean here based on that information because I don't have the rest of the data. A score of what? An 85 represent on the show. The score an 85 on the Boston whisker plot shown refers to, so 85. This number right here is called what? The third quartile. Okay. Like I said, I know we ran through this, but it's not that complicated. 4, what's the median price? Median price should be this guy right here, right? Q2. The median price is 75, so that's our median. What's the value of the third quartile here? Well, all you gotta do is locate the third quartile. The third quartile is this point right here, which makes it 10. 9, 10, 11, 12. 6. Movie theater recorded the number of tickets sold, etc. Box and whisker was made. Let's see which conclusion can be made using this plot. The second quartile is 600. Second quartile is this guy here, Q2. Is that 600? No. Remember, this is in hundreds, so that's 100, 200, 300, 400, so that's not true. The mean attendance is 400. Absolutely not. Because I have no idea, I don't have the list of my numbers, right? I can't add them up and divide by however many there is. So that's definitely not there. The range of attendance is 300, 600. Well, the ranges should be from here, 900, to the smallest, minus 100. So the range should be 800. That's the range. So that's here. That should be the interquartile range, which would be Q3 minus Q1. And that would be 600, right? This is 6 minus 300, right? So if they had said the interquartile range, well, yes, but they didn't. They said range, and the range should be highest minus lowest, 900 minus 100. 25% of the attendance is between 300 and 400. So again, remember I told you, we write 25%. 25%. Each section is worth 25%. So can we say that 25% of the attendance is between 300 and 400? This section right here? Yes. Again, so this would probably be, like I said in class, if there was a question on the test tomorrow, something probably look like this. Based on the box and whisker plots, which statement is true? The median income for nuclear engineers, here it is, the median, is greater than income of all musicians. No, because some musicians earn 125,000. So the median is not greater than all the income from the musicians. So not true. The median income for police officers and musicians is the same. So the median income for police officers is this value right here. And the median income for musicians is this value right here. So are they the same? Yes. So that one is true. I'll do the rest anyway. All nuclear engineers earn more than all police officers. So this whole group of nuclear engineers earns more than all the police officers. No, because these police officers right here earn more than these nuclear engineers. So that is not true. A musician will eventually earn more than a police officer. No, there's some musicians that do not make. This musician here will never make more than the police officer, right? Because police officers, highest one looks like 60. So that's also not true. So the only one that's true is 2, based on the information that's given to you. Well, as you can tell, that wasn't that too complicated. Oh, there's one more. So here we have, oops, let me just make this a little smaller. You had these numbers, 5, 6, 7, 8, 9, 9, etc., all the way to 19. They're asking which of these box plots, box and whiskers plots, represents this set of numbers. Well, the highest, so let me do this. The lower extreme is 5, the upper extreme is 19. So right off the bat, let me just do this again. Lower extreme, 5, upper extreme is 19. So this right here has the lower extreme at 2. So this guy's gone already. It has to start at 5, which 2, 3, and 4 all do. So we need more information. We need to find the median. So the median, let's go find the median, the number in the middle. So 5, 6, 7, 3, 4, 5. So I'm going to go 1, 2, 3, 4, 5. 1, 2, 1, 2. The median is 10. Does any of these 3 have a median of 10? This one has, right here. So obviously, that would be the correct choice. Okay, so this guy right here, this visual representation matches that set of data. Okay, so that was that. The other thing, the other item, not this one. What's this? So this was from the 2018 state test. Just a few things here that I chose. Right, so let me just do this again. Okay, here we go. The store, there's a hat. The price of the hat's X dollars. During the sale, the price of the hat is discounted by 20%. The expression 0.8 describes the discounted price in dollars of the hat, which expression also describes the discounted price in dollars of the hat. So, the other price would be the full price. This is how much the hat is, right? So let's take 20% of that, which is 0.2x. And guess what? If you subtract these two, you're left with 0.8x. Remember, there's a 1 over here, right? So if we do 1 minus 0.2, you get 0.8x. So one way of describing the price of the hat after discount is this, or this. Okay. 2. Which number represents the probability of an event that's very likely to occur? So remember, it goes from 0 to 100% if you're doing percents, or from 0 to 1, right? And 0.12 is 12%, so that is unlikely to happen. 1.3, it's over here, 130%, right? But that's also not what we want. And 0.89 is over here, and 0.89 is 89%. And that's probably the one that we want. So very likely to occur, 89% chance of happening. That's the one we hear. That's the one we want. So C would have been our correct answer. And D is 0.09, which even lower than 12. So I can find 0.09, and that becomes 9%. So the only one that matches would be this one. So remember, it goes from 0 to 1, or a percent as a decimal, or as a percent, it goes from 0 to 100. Okay. Table below shows the number of scooters sold at the store. Okay, in year 4, the store sold 112% of the total number of scooters sold during the previous 3 years. So, on year 4, let me write this. It's 120% of the sum of these 3. So if you were to add these 3, 725 plus 579 plus 696, you get 2,000. So the sum of these 3 years is 2,000. So on year 4, we sold 112% times the sum of that. So we're going to multiply that by 112%. So 2,000 times, let's change that, right, to decimal, 1.12. So in year 4, 2,000 times 1.12, it's so 2,240 bicycles? Sorry, scooters. Okay, so in year 4, they had a huge increase. Okay. Just remember that when you're showing your work, okay, you're not showing your work to me, you're showing your work to a complete stranger. Keep that in mind. Okay, so be organized. Mary's setting up a new tent. The tent came with 7 feet of rope. The instructions are to use 34.5 inches of rope to tie a tarp on the top of the tent. Then the remaining rope should be cut into 8 1/4 sections. Write an equation to determine the number of 8 1/4 sections of rope Mario can cut from the rope. So, 1 foot, or 1 foot, is 12 inches. So let's change everything to inches. So you have 7 feet of rope. It'd be 7 times 12, which is 84 inches. Now, you used a little bit here, 34.5. 34.5 plus, instead of 8 1/4, I'm going to write 8. Oh, it doesn't matter. 825, right? There's one piece that's 34 and a half inches. And then we want to see how many 8.25 sections of rope we can get with how many total? With 84 inches of rope. And that would have been your equation. All right. I don't think I explained that too well, so I'm going to start again. So you had 84 inches of rope. Total. One long rope. From that, you used 34 and a half. Okay. And then with whatever is left over, you want to cut leftover into 8.25 pieces, sections, 8.25 inch sections. So how many of these here can you make with the leftover rope? So that's one way of doing the equation. Okay. Another way, maybe you could have, this is say, write and solve an equation. So some of you might have subtracted 84 minus 34 and a half. Right, so 84 minus 34.5, you have this much left over. So 8.25x, how many of these can fit in there? So that could have been another equation. Both of them would have been correct. And then you just solve it. Okay. '41, a rectangular floor of a classroom. The actual classroom, the floor, is 36 feet. And this is 32 feet. The actual floor of the classroom. In a drawing, right, so in your notebook, you're drawing the floor of your classroom. And it happens that the length is 9 inches, and they're asking you what this would be. Okay, so it's proportional. Okay. So we can say, let's set up proportion. So we can see 36 feet in real life matches to 9 inches on my drawing, and then the width of my the width of the actual room is 32 feet. And we want to know how many inches that would be in my drawing. Cross multiply, we get 36x equals 32 times 9, which is 288. We'll divide both sides by 36, and x equals 8. So in your drawing, the width of the room, of the floor, I'm sorry, would be 8 inches. Okay. Let's see, a computer program selects blue, red, and green as the background color each time the program is used. The program was used 45 times, okay? Of the 45 times, the blue appeared 12 times, so let me write this down. Out of 45 times, 45 total, 12 came out blue, and the red appeared 21 times. Okay, so that's 33. We're missing 12, and what is this? Is there another color? Blue, red, and green. So obviously, even though they don't tell us, obviously the difference here, right? The missing number would be 45 minus 33. That would be 12. So green came up 12 times. Okay, and that's, I guess, the tricky part in this question. They don't explicitly tell you that green came out 12 times. So that is what I would do. Based on the information, which statement about the likelihood of green background appearing on the next program is used is true? Okay, so based on this, and this is your experiment, the probability that a green came out would be 12 out of 45. Right? So let's see. A, green is just as likely as red or blue to appear. No, green is just as likely as blue to appear, but not as a red. So that's not true. Green is just as likely as blue to appear, but not as likely as red. Yeah, I like that one. Green is not as likely as red or blue to appear. No, it's not as likely as red, but it's definitely likely as blue, because notice that blue and green came up the same number of times. So this is not true. Green is not as likely as blue to appear, but is as likely as red. That's not true. Green is as likely as blue because they came out the same number of times, and not as likely as red. So the only one that's true is B. Okay, and again, the tricky part of this question was getting that information. 30. A spinner with 7 equal sized sections was used to play a game. Of those, they spun it 250 times in the first game. Of those 250, the arrow landed on 7. So P of 7 was 35 out of 250. Okay. The same spinner was used 155 in the second game. How many times did the spinner most likely land on 7 in the second game? Okay, so this is experimental, so we're basing it on the previous experiment. Ooh, tricky. So let's say, so we'd be 35 out of 250. That's what it came out in the first game. So we'll multiply that by 150. Let's see what we get. We can simplify. Yeah, let's try to have a calculator. So 35 over 250 times 150. So out of the next 150 times, based on this prior experiment, I would expect it to come out 21 times. Okay. $30.28, going backwards. Oh, so again, this is why I picked this, because I did see these questions on previous tests, and that's why we did what we did today. Let's see, interquartile range, or sorry, Based on the box plots, which statement is true? The interquartile range of the distance for the bus drivers is twice the interquartile range of the distance for the teachers. Well, remember, IQR is Q3 minus Q1. So for the bus drivers, Q3 is 20, Q1 is 10. So 20 minus 10 equals 10. So that's the bus. For the teachers, actually, I don't even have to do it because it says, I'm sorry, the distance for the bus drive, the interquartile range for the bus driver is twice the interquartile range for the teacher. So just look at this box here. Do you think that's twice the size of this? No. The teachers are big. The interquartile range for the teacher is definitely bigger than the bus driver. So you don't even have to do that. It's just visually you can see that that's not a true statement. The range of the distance for the teachers is twice the range of the distance for the bus drivers. Well, it's not twice. It's because the range for the teachers is 35 minus 30, right? Which is 30. And the range for the bus driver is 30 minus 5, which is 25. It's not twice, so also not true. The interquartile range of the distance for the bus driver is 5 miles less than the interquartile range for the distance of the teacher. That could be true. The IQR for the bus drivers, and I know I just did that and I erased it, so it's 20 minus 10, which is 10. The IQR for the teachers is 30, right? 30. Q3 minus Q1 minus 15, and that equals 15. So it's the interquartile range for the distance of the bus driver is 5 miles less than the ones for the teacher. Yeah, ding, 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 we have a winner. And the last one says the range for the distance for the teacher is 5 miles less than the range for the distance for the bus drivers, and that's not true. Even visually, we can see that the range of the teacher is actually greater than the range for the bus driver. So the only one that's true is C. Okay, so another one. Amanda surveyed 13 students. Her data is listed. Which plot correctly displays her data? Okay, so make this a little small. We can see everything. So we have which one matches. Are they what do you call already in order? They are. Thank God. So we know that the lower extreme is 52. The upper extreme is 65. Is anything with 52 and 65? Well, this one is not, so this one's garbage. This one's also is not, so that's garbage. So we're now between, that's gone, between A and B, because those two have the lower extreme, the upper extreme correctly. We need to find a median, so okay, so let's find a median. 1 and 1, 2, 1, 2, 1, and 1, 1 and 1, and it says that the median is 58. So A is correct because A has the median as 58, whereas D has the median as 58.5. So the only correct one that represents that data is letter A. Okay, a farmer grew 19.8 tons in 2013. And then the farm's wheat output increased by 9.8 from 2013 to 2014, and then by 5.1 from 2014 to 2015, which express represents the strategy for estimating the total amount of wheat in tons in 2015. Estimated. So again, the tricky word here is estimate. Because they use estimating, they are going to use friendly numbers. So instead of 5.1%, they're going to use 5%. Instead of 9.8%, they round it to 10 because they're estimating. Anytime you're estimating, you can use these friendly numbers, right? So, and notice that if you look at the multiple choices, 19.8 is now 20, right? So it would be 20 times, and then 2013 to 2014, it increased by 9.8. So 9.8. So let me change that to 10%. And that's 5.1% is 5%. Okay, so in 2000 and from 2013 to 2014, it was by 9.8%. So that's an increase. So remember what 9 point. So you have your 100% plus that 10% takes you to 110%, right? So that increase here. So we're actually multiplying that by, if you change the decimal, 1.10. And then in 2014 to 15, it increased by another 5.1%. So it would be, again, 100% plus 5%, which is going to take us to 105% of what? Of this product right here. So that's going to be 1.05. That's like saying, hey, I bought a t-shirt for $20 and then I had to pay, I don't even know what to say, I had to pay tax of 10%, and then I had to pay another tax of 5%, something like that. So times, sorry. Okay, that's basically what that's saying. And then find the circumference, C equals pi d. I would always draw the circle. The circumference of a circle is 15 pi, so I'm going to write 15 pi here. Okay, what's the area in terms of pi? So if the circumference, so if I know the circumference, I don't know the radius, and I don't know the diameter, but I can find that out. C equals pi d. I know circumference is 15 pi, so I'm going to write 15 pi over here, equals pi d. I can divide both sides by pi, so this and this will cross out, and I know my diameter is 15. So I'm going to write 15. If my diameter is 15, my radius is 7.5. Once I have the diameter and the radius, game is over, right? So I can do A equals pi r squared. Find the area now. The area equals pi, and radius is 7.5. I'm going to take that to the second power. You will have a calculator. 7.5 to the second power. Oops. 7.5 to the second power is 56. So pi times 56.25. And they say leave in terms of pi, so we don't have to multiply that. So we'll just make it a little prettier. 56.25 pi centimeters squared. So that's our final answer. And we have that right here. Okay. I think that's it. Yeah, that's it.